Hey everybody, guess what? It is our last week together. This is the last new bit of information we're going to have, and then after this you will have a chance to make stuff up if there's anything to make up. Otherwise you can enjoy your summer, and we just hope to see you in August, so we can tell you how much we love you and give you big hugs. But anyway, we are going to spot the difference between these two things. So I'm going to read them both to you. Aquan has a bag of candy that contains 2 grape candies, 5 cherry candies, 3 lemon candies, and 4 lime candies. What is the probability that he will select a cherry candy, put it back in the bag, and select a grape candy? Well, I'm going to tell you right now that this line here is the most important line in the whole problem. So let's read the other one and see if we can find anything different. Daquan has a bag of candy that contains 2 grape candies, 5 cherry candies, 3 lemon candies, and 4 lime candies. All of that was the same, right? What is the probability that he will select a cherry candy, not put it back in the bag, and select a grape candy? So if you notice in these two problems, the only difference is here he's putting it back in the bag, and here he is not putting it back in the bag. So basically I want you to think about this. When he puts that candy that he picks back in the bag, nothing has changed. Everything stays the same because he's putting back exactly what he took out. Now I'm going to say no change, and I'm going to use a symbol. It's a triangle. The triangle means change. Okay? Now, over here, everything was exactly the same. He selected a cherry candy, but then he did not put it back. So when he went to pick a grape candy, it was not the same. This did change. It changed from the first time because he did not put the candy back. So that did, triangle means change. So let's go to our next slide, and we're going to talk about what these changes or these differences are called. All right. So first we're going to talk about good old independent probability. Okay. And I'm going to make sure I have my stylus with me. I think, here it is. It says, independent probability is the chance that 2 separate, I have to make that a little thinner, aren't I? 2 separate events will occur. Okay, so that means 2 completely separate things will occur. They're not related at all. All right, so the key word to look at there is with replacement. So that means if you put something back, it's going to be an independent probability. Or if it says put back or returned. So something like this: a jar contains 4 blue marbles and 2 red marbles, 5 green marbles, and 1 yellow marble. What is the probability of drawing a blue, replacing it, and then drawing a red marble? Since you're putting it back, there's no change at all to what you started with. So that is independent probability. All right. So let's look at our next example. Okay. So let's look at our next example and see what it says. It says dependent probability is the chance that 2 related events will occur. The outcome of the second event depends on the outcome of the first. So the key words here are without replacement. That means you take something out and you leave it out. You do not return it. Or say, for example, a problem says you ate a candy. That changes everything. So that means that it is dependent. So an example of that would be a jar contains 4 blue marbles, 2 red marbles, 5 green marbles, and 1 yellow marble. What is the probability of drawing a blue marble, not replacing it, not putting it back, and then drawing a red marble? So if you don't put that marble back, things have changed from where you started. So that means that would be a dependent probability problem. All right, so let's go to the next one. All right, here we are going to try to identify some types of probability. And I'm going to ask you the questions that I asked myself. So we want to know, is it independent or dependent? Randy is doing a scientific experiment where he rolls a tennis ball down a hill, then he rolls a bowling ball down a hill. Do that tennis ball and that bowling ball have anything to do with one another? Is anything at all changing? Absolutely not. They have nothing to do with one another. So this is definitely independent probability. Okay? So let's check out the next one. It says, so again, we're going to try to figure out, is it independent or dependent? All right, so a bag contains 5 red marbles, 3 blue marbles. A marble is selected at random and not replaced. When it's not replaced, it changes the number that we started with, right? It's not the same anymore. So that means this has to be dependent probability. Okay? All right, let's look at the next one. We're trying to decide independent or dependent. Holly randomly draws 1 card from the hand of cards shown and does not replace it, does not put it back. So during her next turn, she randomly draws another card. So when she randomly draws that second card, is it the same as when she first started the whole thing? No, it's not. So that means it's dependent probability. Again, if you replace something or put it back, it's independent. But if you do not replace it, it is dependent. You have to remember those key words. Finally, it says Henry has 5 pink highlighters and 4 yellow highlighters. He randomly selects 1 highlighter, gives it to his neighbor. Then he selects a second highlighter. Well, he gave it to his neighbor. So that means the number in the drawer has changed. And if that changes, that means it's dependent probability. Okay? It's only independent if the same amount you picked from the first time is exactly the same thing you're picking from the second time. And in this case, he's giving something away. He is not replacing it. So that makes it dependent. We miss y'all a lot. We really do. Love you guys. See you later.